we can do the same with normal distributions, which are modeled by a special probability density function. We're not going to go over the equation for this probability density function in this course, but if you want, you can easily look it up and see what it is. And that might be pretty cool for some of you that wants a little bit more information. But basically, since we have this theoretical curve, we can model it with an equation, and then using this equation, we can use calculus to find the area under the curve. But we don't need to use calculus because someone else already did, and then they created a special table so that we can always figure out the area under the curve between any two values. We're going to use this table later. First, let's make sure we're all up to speed on the normal probability density function and the area underneath. First, the tails never actually touch the x-axis. They get closer and closer to the x-axis. So the x-axis is a horizontal asymptote. The reason the tails of this theoretical model don't touch the x-axis is basically because we can never be 100% sure of anything. In other words, we could have a value way out here, really far from the mean, like 5 standard deviations away, but the probability of getting this value or lower is very small. And it's equal to the area under the curve. So if we could zoom in, we would see this tail get closer and closer to the x-axis but never touching. And then the area in between the tail and the x-axis, all the way to negative infinity, is the probability of getting this value or lower. We'll go more into depth in that in a second. And similarly, we could get a value way out here, but the probability is very small. So basically what you have to remember is that if we have a certain value, let's just call it x for now, that the area under the curve from negative infinity to x is equal to the probability of randomly selecting a subject in our sample less than x. And this is equal to the proportion in the sample or population with scores less than x. If this probability is 80%, then we say x is the 80th percentile. If this probability is 90%, we say x is the 90th percentile, etc. If this is a little confusing, don't worry. That's the whole point of this lesson. You're going to get really comfortable with using the probability density functions and analyzing this area, and finding this area.